Hi, so today we will be testing 3 headphones, the Skullcandy Hesh headphones, the Audio-Technica ATH M50s, and the Beats Solos. To test these, we will use the pulse wave generator and the pulse software on the computer to record data. This is Pulse. Pulse is a random wave generator that generates sound that covers all frequencies. So to test these headphones and the frequency range and the equalization, we will use this principle. So we first have this one output, which is white noise, and it's split into 2. The first section goes directly back into the input so we can record what we're outputting. The second output goes into an amplifier to make it louder, and then connects directly to the headphones. The headphones play the white noise generated by Pulse, which is recorded by this microphone inside the mannequin head. And then this microphone goes back into input 2, so we can compare the original sound from the sound changed by the replication of the sound through the headphones. Results can be obtained with this setup here, and we can interpret the data by analyzing the input from input 2 versus input 1. Now this is larger than the ear's frequency response. So this will show the frequency that the headphone is displaying. This here is the frequency range of the headphones, wherever this drops off. The equalization can be obtained by sort of getting an average curve for the frequency. So hypothetically, this would clearly show a base equalization because the volume of the lower frequencies are much louder than the volume of the higher frequencies. So for the third test, sound reduction, we will have to modify the setup slightly. So instead of having the amp plug into the headphones, the amp will route into speakers. There's my beautiful rendition of a speaker. Anyway, so the speaker will play the white noise, and the white noise will penetrate through the headphones depending on how good the seal of the headphones is. So if we again go back to the same graph, we can get an average sort of volume picked up by this microphone. Now the better sound canceling the headphones is, the better the seal is, the lower this frequency is going to be, because less of this noise is going to be penetrating through the headphones. So there are a few ways that we attempted to reduce error in this experiment. The first way we attempted to reduce error is with Pulse. Because Pulse is a random wave generator, we don't have the bias of a specific song with heavier bass frequencies or heavier treble frequencies, which for this test would penetrate the headphones differently. And for that test, of course, we would get an inaccurate frequency display. The second way we tried to eliminate error is we bought a styrofoam head so that the headphones would fit around the microphone like an actual headphone would fit on a human head. And the microphone is placed sort of where the ear canal would be, so we would get the most accurate recording. The third and final way we reduce error is actually just the Pulse software itself. When the Pulse software takes measurements such as this, it actually takes almost an instantaneous 100 measurements at one time and averages them to give you this graph that you see here.